Welcome everybody, and thank you for joining our Research Tuesdays event, Ready for Liftoff. I'd like to start by acknowledging the Kaurna people, the original custodians of the Adelaide Plains and the land on which the University of Adelaide's campuses at North Terrace, Waite and Roseworthy are built. We acknowledge the deep feelings, thank you. We acknowledge the deep feelings, of attachment and relationship of the Kaurna people to country, and we respect and value their past, present and ongoing connections to the land and cultural beliefs. My name is Alice Miller and I'm a researcher in natural hazards and environmental engineering here at the University of Adelaide. I'll be your MC tonight, where we'll ask the question, are our systems keeping pace with how fast humanity is racing to space? As we prepare to establish human outposts on the Moon and Mars, many legal, logistical and ethical questions remain. Our speakers tonight are working to answer these questions. Professor Melissa Deswart is the Deputy Director of the ARC Centre of Excellence in Plants for Space, and Professor of Space Law and Governance at the Andy Thomas Centre for Space Resources at the University of Adelaide. Associate Professor John Coulton is the Director of the Andy Thomas Centre for Space Resources and an Associate Professor within the School of Architecture and Civil Engineering. Please join me in welcoming our speakers to the stage.
Thank you so much for that kind introduction, and particularly thank you for the acknowledgement of the role that the Kaurna people play in teaching us about custodianship of country. And we have a lot to learn in terms of our relationship with space from that relationship to country that our Aboriginal and Torres Strait Islander people teach us. So I'm very excited to talk to you this afternoon about the work that we are doing, and also looking forward very much to the questions that you will ask us. And we've already had a few interesting questions sent in to us, so I can see we've got a very engaged audience. But I always start by asking, what are the questions that we are engaged with right now in terms of planning to go back to the Moon and then onto Mars? So we know that there is a large number of civil and commercial activities. There's a lot of interest in going to the Moon and then onto Mars. But what are the questions that we should answer in terms of humanity's participation in those missions before we go, not after we go? So some of the things that I'm very interested in, and that the centres that we work in are very interested in, are the questions of, well, who is space really for? Is space a place only for nation states? Is it only a place for commercial operators? How do we ensure that there's equitable access to space? So a lot more countries are able to access the space environment now, but does that mean that space is more equitable? How do we protect space as an environment? Because it is very different from Earth, and the things that we know about environmental protection from Earth assume things like biological regeneration or operation of water and things that we don't have access to in many of the space environments. Very importantly, how do we prevent conflict in space? How can we live and thrive in space? So it's not just a question of being able to get there and do what we need to do, but how are we going to have good, meaningful, fulfilling lives when we're there? From an Australian point of view, what is Australia's place in space? I always get very sort of concerned when people say, but Australia really isn't a space operator. We actually have a long heritage in space activities. We regard ourselves as, and I hate the term, a middle space power, whatever that means. But we have a role to play in space. What is that? And who makes the rules for space? So lots of questions that we can ask. We won't get through all of them this evening, but let's see which ones we can address. So as you have already heard, John and I work across a couple of centres here at the university, the Andy Thomas Centre for Space Resources, which we're going to talk to you about, but also the ARC Centre of Excellence in Plants for Space. And what we are really dedicated to is enabling humans to survive and thrive in space. So we're not going to spend a lot of time talking about Plants for Space this evening, but it is an ARC centre. It consists of 5 Australian universities, the University of Adelaide and Flinders here in South Australia, the University of Melbourne and La Trobe in Victoria, and the University of Western Australia, along with dozens and dozens of international partners, universities, space companies, and also space agencies like NASA and the European Space Agency and the German Space Agency. And what we're looking at there, again, is this question of how can we improve human life in space, and what do we need for people to be able to live and work in space in a healthy and meaningful way. So I said I'm going to quickly run through a whole lot of topical issues for you and things that preoccupy us in the work that we're doing in my team. And one of the most important of these is, what role does law play in shaping space? And this is always a sort of very contentious thing, because space law is international law, and the first thing that people always ask me is, yes, but how do you enforce international law? Is it even meaningful? It is meaningful. It is difficult to enforce law in space because it doesn't depend upon the traditional boundaries that we use to enforce law. Why is it that the Australian government can enforce domestic law on us? Because we all live and work in Australia, and the boundaries are defined by essentially our coastline. So it's very easy for us to understand why law applies in that way. When we get to space, you have the big void of space. You have the great question about where does space begin? And all of the things that we are talking about in space, the moon, for example, is very different from the asteroids, is very different from Mars, is very different from a lot of the other planets. So it is difficult to say, well, law can apply uniformly once we move beyond low Earth orbit. Some of the questions that are generated by legal principles in the way space is being used at the moment are things like, what does it mean when China might get to the moon and plant a flag on the moon? How does that balance against the American flag that was planted by the Apollo missions? Other things that have been talked about are things like Space Force and using space as a warfighting domain. Can we have weapons in space? Can we have nuclear weapons in space? And things that keep me awake at night are potentially putting more massive things like mega constellations into low Earth orbit, which create hazards for people operating in that domain, which is where the International Space Station is, and it's where the China Space Station is. So how does law regulate these activities? So a lot of people say space is the new Wild West. Okay, so that then begs the question is, what then do space lawyers look like? If space is the new Wild West, is this what they look like? AI-generated, six-fingered, lasso-toting people? No, I like to think of space lawyers more as the well-attired people here who, because we're lawyers, we're basically only partially human, so we only need to wear a helmet to give us the air to breathe. So just to say that there really is a lot of law already in space that tells states how they should behave with respect to one another in the space environment. Now, most of that law was developed in the 1960s, so it was very much law that was developed in the Cold War era, at a time where you had 2 great superpowers who had the capability of getting to space and were racing one another to get there. So the USA and the USSR, and much of the work that was done on those treaties was really in the guise essentially of an arms control treaty to prevent sort of the weaponisation and the use and detonation of nuclear weapons in space, once they'd worked out that that was a really bad idea because they're essentially not targetable and could end up causing havoc all over the Earth, so destroying the Van Allen belts and things that protect the Earth that we have. So there's plenty of space law, and it tells us how we should behave in space up to a certain point. But it's not just lawyers who have the right to be able to tell us how we should behave in space. And I am really passionate about getting people to think clearly about what are the ethics that should apply once we go to space, or how we're going to space, or who is going to get there. And of course, much of the science fiction that we all know and love is very much dedicated to these kind of thought problems, like how is it that we should decide who should go to Mars? And when they're there, should they be terraforming Mars? Should they be making it a place where it just looks like Earth? Or should Mars be protected because in itself it's unique? How do we look at space in terms of a place where there could be evidence of how life began? So what are the bioethics of space? How do we make sure that when we go to the moon, for example, we don't bring back hazards from the moon? Because that was genuinely a concern in the 1960s, that there might be biohazards there. If people want to take dead bodies up to space, is that something that we should condone? So there is work being done. A lot of it's being done in the fictional space, and here's some books that you might like to read. But there's also now work being done on space ethics and what should be contained within that. So Artemis is the project that's led by the United States. Australia was an original signatory to the Artemis project. We're providing a rover as part of the Artemis mission. And there was a meeting in 2023 when NASA decided that it needed to consider what the ethical frameworks were that affected the Artemis mission. This was the first time that NASA had convened a specific survey or consideration of the ethical frameworks of going to space. It hadn't done so since the Apollo missions. And it said, yeah, well, this is probably a bit late, but at least we're doing it now. And it looked at what the cultural challenges were and what might be the key ethical and societal questions which might arise from humans settling on the moon. As I've said, there's plenty of international law that covers off on how we should behave in space. Australia is a member of all 5 of the international treaties, including the Moon Agreement, which, as you can see, has only 17 states parties. But it does tell us a little bit more about what might happen or what should be done when we're on the point of being able to extract and use resources, which we're going to talk about a little bit more in a few minutes. So there's lots of law. There's lots of things that lawyers call soft law, which is regulations and non-binding guidelines, things like debris mitigation guidelines, safety guidelines, UN resolutions. There's also domestic space law. We have in Australia a domestic regulatory regime which focuses predominantly on launching and return, which I'll talk about in a minute. Also, Article 3 of the Outer Space Treaty is really important because it tells us that states should carry on their activities in outer space in accordance with international law. So it's telling us what the law is that should follow humanity into space. Article 6 is really important too because it tells us that although states are the parties who are bound by international law, states are responsible for ensuring that the space activities of their nationals are in conformity with the treaties. So when, a commercial operator says, yeah, well, I don't know what the law is, it's a grey area, it's not a grey area, it's the law that will be applied to you by the state that is governing your launching. So again, if people say there's not a lot of law in space, you can now tell them that there is a lot, and it applies to commercial and civil operators as much as it does to states. So as I've said, Australia has its own domestic space law, the Space Launches and Returns Act. It was amended significantly in 2018, and it, at the moment, essentially covers space activities that are launch and literally return, because as we know, if there's one thing that Australia is really, really good at, is providing big open spaces. So regulated activities in Australia currently are launch provision, launch activities, return activities, liability for damage and overseas payloads. We don't at the moment have any regulation that applies to human spaceflight, although we do have an astronaut, Catherine Bennell-Pegg. We don't have any laws that apply to resource extraction and utilisation. We don't have any laws that apply to space tourism, and we don't have any laws that apply specifically to on-orbit activities, like activities that could be undertaken on low Earth orbit, for example. However, there's no reason why we can't introduce laws to do this. So there's nothing stopping Australia from being involved in those activities, but we don't currently have a regulatory regime that covers that. So if you're interested in the question of who is space for, you can go from one end of the spectrum, which is David Dewdney's book, which basically tells us that people should not go into space at all because we will end up blowing up the Earth. Literally, that whole book, about 350 pages, is one of the most depressing things I've ever read in my entire life. But, cut to the chase, the spoiler alert is we shouldn't go to space because the capabilities will develop, which will give us the capacity to destroy our own planet. On the other hand, a little book called A City on Mars, which talks about all of the difficulties that humans will face when they go to Mars. And they include things like not only growing food, but also can they have babies? So all sorts of questions there. So there's lots of questions too about preserving space under principles of intergenerational equity, making sure that we can still access space for the purposes of astronomy, and protecting things like the relationship of traditional owners with their right to be able to practice religion, etc., to do with the night sky. So how do we ensure that there's equitable access to space? Well, the Outer Space Treaty tells us that the exploration and use of outer space shall be carried out for the benefit and in the interest of all countries, irrespective of their degree of economic or scientific development, and it shall be the province of humankind. One of the hardest phrases, I think, to interpret for us as space lawyers is, what does it mean when we say the province of all humankind? So we have to give some meaning to that. So the exciting thing for us is we are going back to the moon. Humans are going back to the moon. I am super excited about that. I can't understand why anyone wouldn't be super excited about that. There are two large international consortia who are aiming to do this, by the end of this decade, give or take a few years, one led by the US, one led by China, and they're all aiming for a very sort of similar place, which is around about the south pole of the moon, because it is believed that there is both access to solar power because of the way in which the sun hits that particular point, but also some very cold places where there might be water. So you have a situation where you have two very big projects, both involving both robotic and later human exploration, which are aiming to go back to the moon, but aiming to go to a very similar location. So how can we plan for safe and sustainable activities once we're there? So as I said, Artemis Accords, I think now has, it's actually 56 members. So I have to update this slide every 2 days because there's continually a new number of signatories. The Chinese-led International Lunar Research Station has multiple states, but also has a number of participants who are non-state actors. So again, very similar in terms of the engaging participation from other countries. So the Americans have produced the Artemis Accords produced by NASA. It's not international law, it's not a treaty, it's not agreed to by states, but rather agreed to by space agencies, which give us a new set of rules that build upon the Outer Space Treaty to develop a means of operating together safely. So it does anticipate the extraction and use of space resources, and it also provides for the deconfliction of space activities, which leads us to consider principles such as the creation of safety zones around activities. And John is going to talk to you more about the hazards of working on the moon and why, in fact, we might need safety zones around those operations. So the Artemis Accord says that the signatories intend to use their experience to further develop multilateral efforts for the extraction and utilisation of space resources. Similarly, as I've said, the China-led International Lunar Research Station also talks about the need to develop cooperation and to strengthen the exploration and use of outer space, and also mentions the need to use resources. So that's why I've said that principles such as the development of safety zones is something that is recognised by the NASA-led Artemis Accords. It has been quite contentious, but if you read into the statements that have been made at the UN Committee of the Peaceful Uses of Outer Space, China is also saying that the deconfliction of activities is going to be important to protect the safety of the people who are working in those areas and also the assets. So NASA, there's lots of information again, which John will pick up on, about what are the technical issues that will need to be overcome in terms of operating in close proximity. But the point is that there will also need to be legal and policy guardrails that will mean that those operations can be conducted safely and effectively. As I've said, China also affirms that these sorts of activities will need to be undertaken in a safe and orderly way, and there will be a need to promote the coordination amongst the states. So not a lot of difference in terms of what is being said. So how do we prevent conflict in space? One of the most important ways to do this is by ensuring that we remain open to discussing what the activities are that are being undertaken, and to continue to have those discussions at an international level. Now, the discussion on the prevention of an arms race in outer space has been continuing for over 25 years at the UN and seems to be somewhat moribund, but nevertheless, it is important that those discussions are held regularly because it is part of the information sharing that goes on at a global level. So, Article 4, as I referred to earlier on, tells us that states agree not to place in orbit around the Earth nuclear weapons or weapons of mass destruction. So it is very important that we recognise that that is banned and not turn a blind eye to any states who might be claiming that they do have a nuclear weapon in orbit around the Earth. It also talks about conduct of the establishment of military bases on the moon and places like that, and the testing of weapons is also forbidden. So again, the Outer Space Treaty does explicitly address the need to not use space in a particularly weaponised environment, but it does not prohibit the use of weapons that are not weapons of mass destruction. So there's again a lot of discussion at an international level about what that means for the development of various states' space force. So how do we protect space as an environment? Very important to look at things like the removal of space debris, compliance with the UN long-term guidelines that look at sustainability, that if we are developing resource extraction and utilisation under Artemis and the International Lunar Research Station, that we put in place rules that tell us how we will be able to undertake those activities without destroying the environment of space. So then, that brings us to the question of how will we live and thrive in space? So this is something that we can provide a very meaningful contribution on. So at the moment, the shortest trip to Mars will take you about 9 months. Now, at the moment, when we provide food to the International Space Station, we send all of the food up there. It's all packaged. It's all pre-prepared. The astronauts actually say it's pretty good. It doesn't look that good. It's like, things in a kind of tube. But what they really love is anything that's fresh, crunchy, and different. So the food that they provide now to the International Space Station is sent up regularly. All the rubbish has to be brought back to Earth or burnt up in the atmosphere. But more importantly, it is shelf stable for only about 5 months. So we face the same problem that we had when we had people navigating the world in ships in the 1800s or before then, when they didn't have access to things like vitamin C. So we need to develop food that is nutritious and enjoyable for people to survive on for more than the 5 or 6 months that we can do now. So we're developing things like controlled environment agriculture, looking at developing new forms of plants, but also being able to use genetic modification and synthetic biology to get those plants to produce things like vitamins, nutrition, something like, a nutraceutical or a painkiller, but also things like bioplastics that we can use when we are beyond the ability to resupply like we currently have with the International Space Station. So what's Australia's place in all of this? Well, I think we have some new perspectives to bring with our perspectives from our own Aboriginal and Torres Strait Islander peoples in terms of what it means to be in space and to take country with you. I think we have some very good track record as being responsible users of the space environment, and we've participated in the UN Committee on the Peaceful Uses of Outer Space since the late 1950s. We have space heritage. We have Woomera. We were the fourth country to launch a domestically built satellite from their own domestic territory, and that was built by people here at the University of Adelaide in the physics department and at Elizabeth out at the Weapons Research Establishment. And we're also a signatory to both the Moon Agreement and the Artemis Accords. So this is the vision that I have for space, for when we go to the moon, that we can have people operating together with robots, with thriving greenhouses of really nutritious food that people love to eat, but also which gives them a significant psychological benefit that they will need if they want to continue to thrive and survive in space, and to further humanity in the solar system to discover great new scientific benefits, because space has brought us enormous scientific benefits to this point in time. So I know you might have some questions, but save them to the end, because I'm going to hand over now to John, who's going to take it from here.
Thanks, Melissa. Okay, amazing. When Melissa and I were first discussing how we would put this together, we thought that it was probably good to start with the lawyer, just to assure you that there are some adults in the room asking those questions that you saw at the beginning of her presentation. So Melissa was probably the first of the non-engineering disciplines to join the center, because this is such a fundamental aspect of what we're doing, is making sure that it's being done correctly. So it's not just Melissa. We have an entire space law, policy, and governance group in the center. Raise your hands if you're part of that group for us back there. Yeah, I'm talking to all the young, smart people over there. So definitely a big part of our center. And I really love this picture that she made, because we share the same long-term vision for humanity with regard to our ability to go into space. But I'll go and this is just me. I'm going to make probably the most provocative statement of my presentation. I'm just going to do it right now at the beginning, and that is that from my perspective, this is my belief, humanity has no choice but to become a spacefaring species. That will happen. The only question concerns the timing. So I can sleep well at night because I know I'm going to be proven correct at some point in the future. So somebody who wasn't really a massive advocate of human spaceflight was Carl Sagan, but he was still probably one of the most eloquent writers regarding why humanity should go into space from an existential and an aspirational perspective. But also his quote on this slide is the one that will eventually force us to become a spacefaring species. So, and unfortunately the time tonight doesn't allow me to get into why I believe that, but that is a reality that we will have to face at some point. So the discussion could be on the timing. But I'm really fortunate to be in the Andy Thomas Center for Space Resources at this awesome university. And so we are allowed to actually get after it now in the center. And I'll talk about some of the things that we do here at the university in support of that. So her picture is awesome, but we're starting off with something that's a little bit more limited in scope. So this would be something early on in the Artemis set of missions coming up. And what might this look like? What are some of these things that we need to do at first? So this is a picture of Shackleton Crater. The lunar South Pole is this general area, but just to give you some scale, so the city of Adelaide could fit in the bottom of that quite comfortably. Site 4, that's actually the lunar South Pole, that little divot in the crater rim. So this is, and it's called Site 4 because this was a NASA map looking at where they might be going to land. Site number 1 is on this nicely lit area called the Shackleton Connecting Ridge. And then Site 11 is another area that gets a lot of sunlight on the crater of Dergelash. Now we have some information, quite a bit of information from NASA that lets us understand that although that picture I showed you earlier is the initial base, ultimately the base is going to look something like that. So compare the yellow circle to the Adelaide circle. That's a pretty big piece of terrain. Now, the Andy Thomas Center for Space Resources is located inside the School of Architecture and Civil Engineering. So we are not a space mining thing. We are a civil engineering and architecture and humans in space operation. So when you look at that yellow circle from the perspective of a civil engineer, you get pretty excited because that's 30 kilometers of roads and we have humans at all of these places. So that my road needs to be reliable. I've got to have good, solid communications. I need to be able to replenish the humans at those locations with air and water and food. So these are really great things for a civil engineer to understand about off-Earth operations. So here's one sort of cartoon that we did up in the center. It's, it can't be completely technically accurate because we're trying to stuff a lot of things into the picture to be sort of thought-provoking and show the things that we're thinking that's going to have to happen. But we need to build roads, we need to build habitation, we need to try and use the materials that we find along the way. If we really want to do anything at scale in space, we can't bring it all from Earth. 2% of a rocket that goes up is useful payload. The rest of it is the rocket structure and the propellant. So you're talking 2% of a Saturn V was the astronauts, the lunar rover, the lunar excursion module, their air, water, food, etc. So if we can use things that we find along the way in space, we can do a lot more in space. So this picture is showing us using a lot of these kinds of things to build this small base. And underneath the name of the center is our vision statement. So unlike a lot of centers around the world, we are focused on humans. We might look like we're doing a lot of science and engineering stuff, but the word human is in the middle of that vision statement, so that is what we're focused on regardless of what college or school or faculty you sit in. We're thinking about supporting the human. So that means we have all kinds of different disciplines in the center. So look at that awesome list. And everyone's a director because I'm not anybody's boss. We don't set a research agenda for all of our ultra-talented, globally ranked researchers. But look at those different fields, and it's them and their teams researching things to help humanity move forward here. And because of the excellence of those researchers, we are actually, I'm an American, so I don't have to be as modest as all of you Australians are. We are really, really good, and that is being recognized globally by the kinds of people that you'd want to be recognized by. We get calls from NASA when papers get published, and they say, wow, that's state of the art. So we're really, really proud about that. You'll notice at the bottom, we even have an artist, and we're working with more artists. So, see you, Taylor. Thanks. So we know that that's an important aspect of this. We're talking about humans and communities in space for long periods of time, and art, humanities, education, all of that is part of it. Okay, but we need to be connected to the rest of the world, and we are. So we have all these fantastic adjuncts that are part of our program from all the places that are at the leading edge of research in these areas, to include people like Professor Hurdy Miyamoto from the University of Tokyo, who's one of the 7 people on Earth who can name things on Mars. And that's a picture of him teaching into one of our courses just a couple of weeks ago here in Adelaide. So we do all of those things, but where we really stand out globally is these three areas here: off-Earth, civil engineering, humans and human research, and plants for space is one of is really a high point within that research, and then also autonomous systems and AI. Many people don't know, but when NASA held a space robotics challenge, there were 114 teams in that, and we were number 3. We finished number 3. We were the highest ranked university in the world in that challenge, and the NASA engineers who graded it, they can give out a thing called the NASA Innovation Award, and that's just only if they see something really, really impressive, and we got one of those, right? So the Kelvin's Posed Estimation Challenge is another NASA and Stanford prize, and we're the back-to-back winners in that. So we have some really fantastic space cred across all of these different areas. I'm going to show you just some of that here in the remaining couple minutes of the presentation. So we have all of these facilities that the university has helped us to construct, and they're being utilized like you wouldn't believe. So we do have a mission control. We have controlled things around the world, all the top 3 things there: University, Australian, International. We've actually done that. Kids in Tokyo, Japan have driven rovers in our pits, and we gave them little lunar driver's licenses for that. And the Deep Space Network, we're working on that. Come back in a year or 2, and we might be able to take the asterisk off. So right here on North Terrace, right along the main thoroughfare through the campus, you should be able to see this lab. Instead of putting it underground or behind a swipe card access, we put it in the main thoroughfare, and we took out the brick walls and put in big windows. And one big measure of success for us is in this lab, when you're inside it and you're looking out, you can see all the nose prints on the glass, and the more the better. And we get lots of those. So in this lab, we have the first kinds of equipment in the Southern Hemisphere for understanding and being able to try and learn how to operate in an off-Earth terrestrial, in an off-Earth environment, mostly the Moon and Mars, but also for asteroids, and we'll show some of that. Interestingly, we also have a 6 degree of freedom hexapod. So we're getting this qualified for humans again, and we're running, the psychology department here is running experiments here where we're just looking at what happens if you're making different decisions while you're driving, a rover like this. And this is the School of Humanities that had put all this together for us. So what happens if you're and you're driving a lunar rover on the moon? And you have to make different decisions, and the rover is interacting with you, and you're having to think like that. We also have an ISS mock-up module where we're better understanding the role that plants play in human stress in an environment like that. So psychology and architecture working very hard to understand how we can keep the human mind safe in space. But we have a sand pit with some pretty fantastic capabilities in terms of OptiTrack, motion capture, and things like this, so we understand exactly what's happening in that pit. We're looking at lots of different mobility modalities. Then we have a really special thing, and this is a regolith simulant pit. So this is Lunar Highlands simulant, so it's representative of the lunar South Pole. We developed this in concert with our friends up at the University of Central Florida and the Exolith lab there. And we now have something close to 100 tons of various simulants in the lab. So we have looked, once again, at a lot of bio-inspired mobility types, and you can see some gravity offload there on the little kangaroo. We also had the first regolith thermal vacuum chambers. So these are vacuum chambers that allow us to simulate the temperature condition and the pressure condition at a certain place on either the moon or Mars. So we have all the gases necessary to pump into the chamber so we can simulate Martian atmosphere. We also have Martian simulant. And these were the first of their kind in the Southern Hemisphere. So we're a school of civil engineering, so we're trying to build construction components out of these simulants, and of course we have to test them in an accurate environment. So we're putting our vacuum chambers through their paces as we are our civil engineers who are working on these projects. We have lots of different simulants. We're making a lot on our own now, but we have Martian polar, Martian equatorial, and lots and lots of different simulants for different areas and different purposes on the moon. So we're making lots of parts to support the construction of roads and landing pads and habitation facilities, etc. And we're experimenting with multiple different ways of using that material to make these parts. So if you just had a plastic beach shovel and you pick up some lunar regolith, so this is the dust that's everywhere on the moon. It's at least 4 to 10 meters deep everywhere you go. You can't get away from it. But in that shovel, 43% of what's in that shovel is oxygen. And the rest is titanium, aluminum, and iron, and some other things. So really useful material just in that scoop. So what can you build out of all those things? Can you extract the oxygen and use it to breathe, et cetera? So there's a lot of interesting things that we can do with that, and we're learning how to do that in our labs. This is really interesting. This is a vibrating drum roller that we built for a US partner that is contracted by NASA to help them understand how they might help to compress the lunar surface. So NASA has stated they need thousands of square meters of lunar surface prepared for construction activities. We're not going to put a habitation module just on the ground. You're going to do what you do on Earth. You're going to clear the rocks, you're going to level it, you're going to compress it, test it, and sign it over to a construction crew. So we are helping NASA to better understand how we might do that with these scale models. Out at our Roseworthy campus, we built this. So that other lab was on the campus here, and that's research level stuff and research scale. But we want to go bigger. We go out to Roseworthy where we have 4,000 square meter of instrumented terrain, and that's also where we run the Australian Rover Challenge. We'll just let this play for just a few seconds. Is everyone in here aware that we run the world's most difficult rover challenge right here in Adelaide, Australia? Yeah. The world's most difficult rover challenge is here. So we recently went to NASA. NASA holds a challenge called the Lunabotics Challenge. Their entire challenge is 1/16 of what we make our students do. So the students in this challenge have to do autonomous traverse. They have to find water mixed in with dirt, extract the water, process that, and hand a cup of water to the judges. They have to be able to perform inspection, connect hoses, turn knobs, press buttons, and it goes on and on and on. So, and not only is it the most challenging, but it is in Australia, so it's also probably the most fun. So that's what the competition pitch looks like. That's the 4,000 square meter field we have out at Roseworthy. There's a LiDAR capture of that same field, and there's last year's collected set of students and rovers. And you can see the analog facility in the background. And I don't know if you can see this, but this big structure on the right side of the picture is our newest lab that we'll talk about here in just a moment. There's the LiDAR picture again. Right in that spot, we now have an asteroid. So working with Professor Miyamoto at University of Tokyo, we now have put in a permanent asteroid surface in there, and you can see a couple of our different honors groups working on some mobility solutions potentially to move around on an asteroid. And then we have our crater lab. And yes, there is actually a name behind crater. I'm sure you can appreciate the creativity that went into that. But crater allows us a 100 square meter albedo correct lunar simulant bed in a blacked out building where we can then apply a 9,000 watt solar lamp, and we can recreate the really unique and challenging lighting conditions at the lunar South Pole. So there's what the building would look like according to an artist render, and thankfully the university has completed that, and here it is in real life. That's what the artist told us it would look like on the inside, and that picture was just taken last week out there. So really, really fantastic, and we're really lucky to have that. What you see there is a regolith bed, and behind that are habitation facilities for an analog astronaut mission that's ongoing in that lab right now. So we have 4 analog astronauts living inside the crater lab for 2 weeks, conducting a number of different experiments, including EVAs in these spacesuits, and working in the regolith bed under those lighting conditions. So there's another picture. I just thought it'd be cooler to get a little close to the dirt. And there's our director of astronaut autonomy teaming standing there making all kinds of plans for what she's going to be doing out there with our analog missions going forward. By the way, one of our PhD students is one of the world's foremost analog astronauts who was the director of operations at the US analog operation in Hawaii. So we're attracting global talent into the University of Adelaide and Adelaide University, and we're really proud of that. Just another shot of the habitation modules. And then I'll just finish up. We are not only researching all these things that we are sought after as members of real missions in space. So we were a supporting partner in both the M1 and M2 missions that iSpace recently made to the lunar South Pole. We have continuing inputs to those projects. How many people know about this? Artemis 3, the first human return to the moon. When that first woman gets to the bottom of the ladder, she might want to think some really philosophical things, but she won't have a lot of time because there's actually work for her to do. So she has 3 lunar surface science experiments that she'll have to actually physically deploy, and the University of Adelaide is partners in 2 of those experiments that were selected by NASA from obviously quite a number that were submitted. So of the 3 that'll happen on that mission, University of Adelaide is part of 2 of those. And finally, Australia is building a rover to go back to the moon, and we are a consortium partner that's doing a lot of the environmental testing for that rover, from the machine vision in crater to environmental in the regolith chambers, et cetera. So we're doing quite a bit of work to enable that rover to have a successful 14-day run on the moon. And that is the end of the presentation. I think we might move into questions.
Thank you both. What an exciting topic. I'll invite you both up and we'll now take some questions from the audience. I'll start with a pre-submitted question. So, can any of the discoveries resulting from these missions assist in protecting life on our current planet, Earth?
Yes, so I think I alluded to this about the research that has been done, particularly thus far on the International Space Station, which is essentially an amazing research laboratory. And so what we learn about the behaviour of certain things in space will assist us to understand both how we can, say, protect the Earth from threats from space, but also enable us to develop novel technologies that we can use here now. Plus, in addition to that, a huge amount of environmental science is supported, of course, by Earth observation satellites. So a huge amount of science that is very beneficial to Earth is being done both in space and from space that will help us going forward. And that's why it's so important that, the International Space Station project of doing, really important fundamental science needs to be maintained.
We'll take some questions from the audience now. We've got some microphones if people just want to put their hands up. We've got one at the front just here on the right-hand side.
Good evening. I wondered if scientists had made any advances in protecting astronauts from space radiation, because I had heard that our very own beloved and esteemed Andy Thomas might have contracted Parkinson's from his exposure to space radiation in his 141 days in space. I know you showed those wonderful pictures of those space habitats on Mars. Would they not be better building them underground, perhaps, at this stage?
Great question. And yes, I have some other slides that show sort of a pretty base on Mars, and that's maybe with everything on the surface and glass domes and things. And then we overlay that with a more realistic base on Mars, which you can't really see because it's underground. And of course, then also lunar lava tubes are of interest because that provides a space that's underground, so it's a thermally benign environment, but more directly to your point, it protects against the radiation. So typically on the moon, from a solar particle event, you can pile the regolith up on top of a habitation facility, and that's going to help you out to a very large degree. But probably being underground is going to be even better. So there's a lot of thought going into that. Astronauts, but especially government astronauts, might be considered risk takers. But there's also a lucrative post-NASA career waiting for you. So they're not necessarily eager to have some of those things. So we're learning about that, and there's a lot of research going into how we will protect people from that, especially if we're talking about long-term space flight.
So as I would add to that too, that one of the things that we don't talk a lot about is space weather that has an impact on Earth. So there's a lot more work being done now through the Bureau of Meteorology that has its own space weather expert team that helps to predict things like solar flares that can produce pretty catastrophic events on Earth when we get a solar flare that can do things like knock out the entire power network and those sorts of things. So yeah, once we get beyond that amazing miracle protection that the Earth has, the effects of radiation really do need to be taken into account for all sorts of activities. And I don't want to freak anyone out, but there is a new form of bacteria that they've discovered on the International Space Station that's probably there because of the effects of radiation.
Great question. I think we had another one in the middle.
Hi. Thank you again for your talk. My question is, what are the pathways for someone like me? I study AI. I'm almost finishing. What are the pathways of someone like me joining your team or collaborating with your team after I graduate or while I'm still studying?
So this is something. This is a great question. And it's one that we're wrestling with. Your particular discipline is probably one of the easier pathways. So we have recently, we had quite a number of scholarships that we have given out to space architects and space psychologists and civil engineers. And one of our civil engineers recently just graduated with their PhD, and they wanted to go, ideally, they would like to go to a space company that's doing lunar civil engineering. And of course, nobody is feeding their kids or buying a beach house using income from lunar civil engineering. One of the things that we have the luxury of doing at a university is we can get pretty far out in front and research those edge cases and get into these really interesting areas that haven't yet caught up on the commercial side. So we have that luxury to do that. But what happens to our students that specialize in these kinds of things when they graduate? Well, they're snapped up instantly by terrestrial companies that are thinking about these kinds of things because they're fantastic engineers. So we have this problem across all of our PhD students that are engaged in this kind of research. But as Melissa alluded to, all the space research translates really, really nicely back into the Earth. If you're taking your discipline and you're applying it to space, you're applying it to probably a much, much tougher place. So it might be the same equations, but in terms of circularity, needing to have no waste, operating in a very harsh environment, you're going to be better trained than, I would say, others who hadn't had to deal with some of those particular problems. In your particular case, we work with a lot of folks from AML and computer science in a number of the projects that we're running. So you're in a good spot.
Great answer. I think we had another question over on the side here. And then we'll probably take one last question in the middle.
What sort of energy production system do you think the new lunar rover will use?
So the one that was on the screen, the little rover that was on the screen here, this one? Yeah, so this one has, I don't know if you can see, it's got little solar panels around the sides. Because on the lunar South Pole, the highest the sun ever gets is 1.5 degrees above the horizon. So it's always just like this. It's like you're living in Finland or something, but it's just like right there in your face. So that's why you'll see that rovers going to the South Pole have solar panels on their side versus the ones going to Mars, typically the solar panels face up. So the ones going to the lunar South Pole face sideways because that's where the sun is going to be. But we also have other plans for how we might potentially power these kinds of places. And on the moon, it typically goes back to solar energy. As Melissa said, the lunar South Pole does contain some areas that might be able to see the sun for 80 to 90% of the year. And if you put that solar panel on top of a 50-meter tower, then you can see the sun all year round as it goes around you at positive 1.5 to negative 1.5 degrees.
Very interesting question, thank you. We'll take one last one in the middle here. Yep.
I want to ask a question about quantum physics and I can't work a microphone. Everybody's pretty excited about quantum physics, and what I hear is it's not a better way of doing digital stuff. It's an entire new universe. It's an entirely different way. Are you talking to the quantum people in developing various things? If it's such a revolutionary jump and feels like you're trying to make a revolutionary jump, is there room to build it in at the beginning? And a very quick question at the end, what's an analog astronaut? Is that a person? Thank you.
We'll start with the easy one. The quantum one? Yeah. You want to take that one? Sure. So the people in the center who would be expert in that are the folks that work at the Australian Institute of Machine Learning. And so we have a pretty sizable team over there led by Professor Tat Jun Chin, and they're global experts in that particular space. So I think, so we would probably trust them that once quantum reaches a stage where it's fit for space flight, then they will bring that into the center, and we would work with it. We have nothing against that. We'd love to take advantage of those that step change in performance, but I'm not sure that it's flying just yet.
The only thing I would add to that is one thing that we are very clear on in the centre is that a lot of things that need to happen in space are what we would call like space tradie type of operations. So, we know that, people talk about robotic, this is John's area, not mine, but we talk about, why don't we just send robots? Why don't we just send machines? We don't have to worry about people. But the conditions that we know will be encountered, like on the lunar surface, are conditions that robots, however they are configured, whatever controls them, may not be able to really survive. So the way in which, regolith behaves is still not really well understood. And so we literally are at the point where you are going to need the astronaut there with a broom, wiping the regolith off the solar panels to make sure that the, water machine continues to work. So space still does depend upon a lot of very fundamental skills.
Great.
Yep.
Thank you so much, everyone, for your questions, and thank you for the brilliant answers. We'll have to finish with question time now. I'd like to extend another huge thank you to our speakers tonight, Professor Melissa Desvort and Associate Professor John Colton. Thank you to everyone in our audience for attending. Be sure to sign up to our mailing list to receive the latest information about Research Tuesdays, and have a great rest of your night. Thank you.